All right, what we're going to do now is go through the data portion of our lab making copper oxide from copper carbonate basic. So our copper carbonate basic was our green chemical, and so here's our formula for that. And the chemical that we made, which is our black chemical, copper oxide, CuO. I'll highlight that in orange. I'm not going to highlight in black because it'll cover up. So now what we're going to do is analyze sort of the data, what happened in the lab, and try to figure out how many grams of copper oxide we should have made in our lab. Okay, so let's get to it. So what I've got here is the masses that I got from our lab. We weighed out 1.20 grams of copper carbonate basic. The mass of our empty test tube was 13.22 grams, and our mass of our copper oxide in our test tube was 14.03. So the first question says, how many grams of copper oxide did we make? So we're going to take our mass of our test tube plus our copper oxide, 14.03 grams, and we're going to subtract out our mass of our empty test tube. Okay, so subtracting 14.03 minus 13.22, we get 0.81 grams of copper oxide. And that's how many grams we made experimentally. So the question is, how many grams should we have made? So that's what our next portion is going to cover. Now, when we were started the lab, we were supposed to weigh out about 1 gram of our copper carbonate. But I added a little extra and I didn't want to dump anything out. So in our lab, we didn't weigh out 1 gram, we weighed out 1.20 grams. And so that's the value that we're going to start out with. Okay, so our question is, if we have 1.20 grams of, let's just call it our green chemical, okay, which is our copper carbonate basic, how many grams of copper oxide should we have made? Okay, so now what we're going to do is, first step is, when you're kind of comparing two different chemicals, we know we're going to have to use our equation. Our equation says that for every 1 mole of copper carbonate basic, we should make 2 moles of copper oxide. So we have to use our equation to be able to compare these chemicals, except for the equation is in different units. So the first step is convert from grams into moles of our green chemical, our copper carbonate basic. So we're going to put grams on the bottom for every 1 mole on the top. Okay. And my molar mass of copper carbonate basic is 221.1 grams. Okay. So what that's going to allow us to do is cancel out these units of grams, and we're left with moles. And then at this point, if we stopped and calculated, we would be left with moles of our green chemical. But we're going to string our calculations together. And so I now need to put moles of my green chemical here on the bottom. And kind of string this together a little bit. And I'm going to have moles of my copper oxide on the top. And from the equation, there's 2 moles of copper oxide, so I'm getting that from here, and 1 mole of our copper carbonate basic, so I'm going to put a 1 on the bottom. My units of moles of my green cancel out, and now I'm left with moles of copper oxide, and so now I need to do one more step, one more conversion. So to cancel out moles of copper oxide, I put that on the bottom. And my molar mass of copper oxide, for every 1 mole, it'll weigh 79.5 grams. Okay, I'm just going to erase this for now. So for every 1 mole. My units of copper oxide cancel out. And now I'm just left with units of grams, and I should be a little bit more explicit here. That's grams of copper oxide. Okay, so the only units I have left are grams of copper oxide, which is the units that I want. So now it's a matter of doing the math. So take 1.2 times 2 times 79.5 and then divide it by 221.1. And what we get is 0.86 grams of copper oxide. So what this tells me, this is what's called the theoretical amount of copper oxide. That if everything went perfectly in my lab, I should have ended up with 0.86 grams of copper oxide. If you compare that to, so let's go ahead and label that just so we have this in mind for later. This is what's called the theoretical amount. Okay, let's see if I can move that over a little bit. Nope. Anyway, that's our theoretical amount of copper oxide. Our experimental amount is up here at 0.81. So as a chemist, one thing that we could do, and which we'll do in another lab, is compare our experimental amount to our theoretical amount. But our theoretical amount always lets us know how close we, or what we should have gotten in the lab, and it's always a good idea to compare what you should have gotten to what you did get. Okay, thanks for watching.